In problem number 16, we have a function, this is Greek letter omega. Omega of t is equal to 8 plus square root of t, all divided by t squared. So what this equation signifies in this problem is that t is the number of minutes after liftoff, and omega of t is the rate at which the rocket is consuming fuel at that moment. So when we plug in like 2, for example, that would mean at 2 minutes, it's burning this much fuel per minute in liters. So this much liters of fuel per minute. So we don't have keep in mind, this is not showing us an actual amount of fuel that has been used. This is giving us the rate at any moment. So remember that since you have if you take an amount and you do the derivative, you get a rate. It stands to reason that if you're given a rate, you would need to do the antiderivative to get an amount. And that's what we're going to need to do here. So we're told that if 2 liters have been consumed after 1 minute, how many liters will be consumed after 4 minutes? So when a question is phrased like that, where they give you one scenario and then ask you for another, that should be the clue that you're doing an indefinite integral here, and you're using the first scenario to solve for the constant of integration c. So if 2 liters have been consumed after 1 minute, that means that in our antiderivative function, which I'll use capital omega, if we plug in 1 minute to that, we have to get 2. So this is the amount function, and this is the rate function. This is the antiderivative of this. So we know that if we plug in 1 minute, 2 liters would have been consumed. So that's the amount. We're asked for how many liters will have been consumed after 4 minutes. So we're asked for what's the answer when we plug in 4 to the antiderivative. So to do this, we need to find the antiderivative. So what I'm going to do before we do it is remember, we don't have any sort of quotient rule or anything for finding antiderivatives. So we have to simplify this before we do that. So how can we simplify this? Well, we could divide each of the terms in the numerator by the denominator and then separate them as powers. So this is 8 over t squared. So I'll write that as 8t to the minus 2. The second term plus, we have square root of t over t squared. So that's t to the 1/2 divided by t to the 2, which is t to the negative 3/2. So this expression that I just wrote here is exactly equivalent to this fraction. It's just separated term by term and wrote not as a fraction with negative exponents instead. But that's better because that's a lot easier to take the antiderivative of. So now we're ready to take the antiderivative. Capital omega of t is the antiderivative of this. So we just use our power rule just like we have been in the past. So the 8 would stay there because that's a constant. The antiderivative of t to the negative 2 would be add 1 to the power, so it would become t to the negative 1, and divide by that new power, negative 1. Same process here. We have t to the negative 3/2, so its antiderivative would be adding 1 to the power. If you add 1 to negative 3/2, you get negative 1/2, and divide by that new power, negative 1/2. So let's try to simplify this a little bit. This negative 1 can just be outside here. And I'll write this as fractions now. So this is negative, excuse me, this is negative 8 over t, because this t to the negative 1 means it's on the denominator. A negative 1/2 in the denominator would be a minus 2 in the numerator, and this t to the negative 1/2 is in the denominator here. And we have our ever-present plus c. So this underlined portion right here, that is our antiderivative of this function. So we're going to use that to answer the problem now. So remember, we were looking for what do we get if we plug in 4 to this? Well, we can't know that right now because there's this unknown c, but that's where we use this. So we know that if we plug in 1 for t, it has to equal 2. So let's figure out what that is. If we plug in 1, this becomes pretty simple to get. Negative 8 over 1 would be minus 8. Negative 2 over square root of 1, which is 1, would be minus 2, plus c. And that we know that that has to equal 2. So you see that allows us to find c. So this is negative 10 plus c equals 2, so that would tell us that c is equal to 12. Now that we know c equals 12, we know our antiderivative function more precisely. Negative 8 over t minus 2 over t to the 1/2 plus 12. Now we know that's our antiderivative function for sure, and therefore we can answer the question, what happens when we plug in 4 for t? So this would be negative 8 over 4, which is negative 2. Negative 2 over the square root of 4, which is 2. So negative 2 over 2 minus 1 plus 12. So that's negative 2 minus 1 plus 12. That would give us 9. So after 1 minute, the rocket had consumed 2 liters of fuel, and after 4 minutes, it had consumed 9 liters of fuel. The way that this problem was worded, you also could kind of check your answer, because you know that this number has to be higher than 2, because it's consuming more fuel as time goes on.
The Teaching Center, UF's Learning Resource Center.